Hi everyone, this is going to be our note for 6.6, more transformations of the sine function. Last lesson we did horizontal and vertical shifts. So this lesson we're going to incorporate what the a value means, but it means the exact same thing as when we did our quadratics. So first let's just do a quick review of what c and d mean in our equation. So far our c value causes a horizontal shift. If c is greater than 0 degrees, it's a positive value, the sine curve shifts c degrees to the right. So whatever c is, if it's like 45 or 15. If c is a negative value, the sine curve shifts c degrees to the left. So if c is a negative number, it'll go in the negative direction. Keep in mind, whatever you see in the equation, that will be the opposite of what it is. So I don't want to get too much into that. I think you know what that means. I'm going to keep moving on. Also notice that this horizontal shift doesn't really affect any of these things. For our sine function. It doesn't affect the equation of the axis, or the period, or the domain, or the range, or the amplitude. So our next value is the d value, which is a vertical shift. So if d is greater than 0, a positive value, it's going to shift d units up. One unit up, 2 units up. If d is less than 0, it's a negative number, it's going to go down. So shifting down 2 units, 1 unit. This affects the equation of the axis, because remember the equation of the axis is that middle point between the max and the min, and that value is recorded on the y-axis. So shifting the graph up and down, or shifting our curve, up and down, is going to affect where this equation of the axis is on the y-axis. It also affects the range because it affects the max and the min values. So if you understand that idea of c being the horizontal shift, d being the vertical shift, we're now going to look at what the a value represents, and just like in quadratics, it denotes a stretch or compression as well as a possible reflection. So a lot of words in it. So let's go over the first part, stretch or compression. We said if a is a value that's greater than 1, so like timesing it by 2 or by 3 in the equation, so like let's say like y is equal to 2 sine x, a number greater than 1. Then we're saying that our curve is going to be vertically stretched. And if a is between 0 and 1, and again we see these absolute sign meaning it's a positive value, and if it's between 0 and 1, this means it has to be a fraction. So like y is equal to 1 over 2 sine x. If it's a fraction, then it's got to be vertically compressed. And lastly, if a is a negative value, then the sine curve is reflected in the x-axis. So to summarize this, or what we're going to do anyway for how we do this, remember what we did last time? We had our 5 key points. Our 5 key points are here from our graph of just y equals sine x. So we have 0, 0, 90 and 1, 180, 0, 270, negative 1, 360, 0. Just like remember for our parabolas when we did this, our parent function was like this, and we had this, 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, like that. These are key points for the sine function. That's good to remember. So to sketch a transformation, we're going to simply transform the original 5 points that we have above to their new locations, and join the points with a smooth curve. So remember to follow our order of operations when we're doing this, if you forget the order in which we have to do this. So here's our equation if we're doing transformations for the sine function. And let's focus on the x value. As long as we follow BEDMAS, we'll do everything in the correct order. So according to BEDMAS, I would do my brackets first. So first thing I'm going to do is do the c value, which is the horizontal shift left or right. And that's going to affect the x value, or the theta in this case. Then we're going to, after we do the things in the brackets, BEDMAS says to do multiplication next, so then I'm going to do the a value, which is doing the stretch or compression, and then also any reflection if we need to. And then lastly, we do addition, which is the vertical shift, either up or down. That's going to affect the y value. So as long as we follow this order, we can do any kind of transformation for sine functions. So let's get to an example. It says consider the function y equals negative 2 sine theta plus 90 degrees minus 1. So it says list the transformations using the a, c, and d values. So let's start with, well, let's actually go in order based on BEDMAS, how we would do our transformations. So first I'm going to start with the c value first. So our c value is equal to positive 90 here, which means the C value has to be negative 90 degrees. And this negative 90 means we have a horizontal shift left 90 degrees. We then have our A value to do next. A is equal to negative 2. So as soon as we see the negative in the front, that automatically tells us we have a reflection in the x-axis. There's also with the A value, this 2 means we have it's a whole number, it's not a fraction. So we're going to have a vertical stretch by a factor of 2. Then lastly, we do the addition part, which is our D value. D is equal to negative 1. So in this case, we have a vertical shift down 1 unit. So these are the 3 different transformations, I guess 4 if you count the A value doing the reflection. These are the different transformations we're going to see for this sine function. So if you know our 5 key points, we can do all these transformations on the graph if we were to graph them, or we can just calculate it like we've been doing in the past. The only difference now is we're going to incorporate that A value where we have to stretch or compress it, but we're still going to do it in this order. So I'm going to do the first one for us. I'm just going to go all the way across. When you do more of this or you want to, you might want to just work downwards and kind of do it just to get your values, but I'm going to go all the way across for one of them, and then you can pause it, try it on your own, and then check your answers with me. So for the first one, we're going to have a phase shift left or right. Well, we said it's negative 90, so we're going to go to the left, and we have this minus 90. I know it's in the brackets here. In this one, it's plus 90, but we mean here we're going to move to the left 90. So I just mean it like that. So I'm going to have 0 degrees minus 90, which is equal to negative 90 degrees. We saw that before in the last unit where we can still go to negative degrees on this side if we need to. So we have negative 90 degrees. Is there a stretch or compression? Well, we said it's a whole number, so we're going to have a stretch. And we said it's a negative number, the A value, so there is going to be a reflection. So our Y is going to be multiplied by negative 2. So the Y value in this case is 0. 0 times negative 2 is still 0. And now we do our vertical shift, up or down. We said it's a negative 1, so we're going to shift down, because it's minus 1. So we're going to have 0, which is our value from here, minus 1, which gives me negative 1. So our new point is going to be what our new x value is, which we had as negative 90 degrees, and our new y value, which is going to be the negative 1 here. So pause the video, try filling in the rest on your own. The part to remember is that we have to use this value into our vertical shift, and that this answer is going to be our transformed point for the y value. So pause the video and then I'll fill this in too. So here is the table. If you want to pause the video again just to check your answers with what I have, that's fine too. Here are transform points, and we're just going to plot these on the graph now. So again, if you want to pause the video and then graph it, you can do that. Maybe you've already done that, but try doing that now. So here's hopefully what our graph looks like. It's kind of hard to put the first point in because it's negative 90 is down here, but we can assume that if we're starting at 0, negative 3, that the curve is just going to go somewhere in that direction. So I just drew this dotted line to show that it's going to go over there. Likewise, we have it finishing at 270, negative 1, but because this is periodic and this is going to be a repeating pattern, we can assume with this dotted line that it's going to keep going all the way to 360, negative 3 again, and then repeat the pattern over and over again. So we can see our transformations. We did move everything 90 degrees to the left, and then we did a vertical stretch. You can see that the amplitude here was from 0 to 1, and now our amplitude is going from -1 to 0 to 1, so it has doubled. And you can see that the maximum was here, but it's almost like it's been reflected and then moved over here. So all the transformations seem to be in place. So maybe not in the order that I set them in, but they seem to be all there. So let's take the domain and range for the new curve. The domain is x is any real number still, because, again, I forgot my arrows, but these will continue to go in these directions for as far as we know. And then the range is now going to be y is any real number, but the maximum value is 1. So y has to be less than or equal to 1, but greater than or equal to the lowest value, which is -3. And to state the equation of the axis of the curve. So I can get my max and min values, add them together, divided by 2. I could also eye it. We also just kind of see it. So -2 divided by 2 is equal to -1. So that is at -1. For your next example, we're just going to get some descriptions, and then we're going to make the equation. So remember, our equation is like this. And we'll apply all the transformations in for these letters. So a phase shift of 25 degrees to the right. To the right means it has to be a positive value. So if I put a positive value in here, it's going to appear negative. So I'll just do it. I know the last video said I wouldn't show up. I'm going to show it here anyway. So we're going to have minus positive 25 degrees plus d. I don't know why I made the degrees outside of that. Okay, and then we don't know what d is yet. So then we can do the vertical translation up 3 units. So the d value now is going to change to plus 3 because we're going up. And then it's stretched by a factor of 3. So because we have a whole number, a is going to be stretched by 3. And there's no talk about a reflection, so it's going to be a positive a value. So now when I simplify this, this will simplify to give me y is equal to 3 sine x minus 25 degrees plus 3. So again, even though it's moving to the right, in the equation it's going to appear negative. All right, for b, we have a phase shift. I'm just going to write the equation like this. I'm not going to write the whole thing again. We have a phase shift of 35 degrees to the left. So the left means we're going to have a negative value here, which means if I have a negative value in here, it's going to appear like that. A vertical translation, 5 units down. So instead of plus d, it's going to be minus d. Or we can think of it like plus minus 5. And then compressed by a factor of 0.5 and reflected along the x-axis. So reflection means we have to have a negative in the front, and the factor of 0.5. I can just put 0.5 here. Since they gave us a decimal in the question, we can leave it as a decimal in there. And then when I just simplify my signs here, I'm going to get y is equal to 0.5 sine, negative 0.5 sine x plus 35 degrees minus 5. So you don't have to write this equation. I just did it to hopefully show you how our signs are changing, but you can just go straight to this solution. So that's how you make an equation based on these descriptions. Our next question is to sketch y is equal to 1 over 2 sine bracket theta minus 120 degrees bracket plus 2, indicate the domain, range, amplitude, phase shift, and vertical shift, write the equation of the axis of the curve. So basically what we did in the last example. So what you can do is try this on your own and then check with my answers momentarily. All right, so here are solutions. You just tell I actually made a mistake. I thought there was a negative there and I had to change it. So here are solutions. First, we started with a horizontal shift because it's negative. In actuality, it's a positive 120, so we're going to move to the right. So all of these values are going to move to the right 120, so we're going to add 120 to all of them. and I get these values. Then we have a compression, because it's a fraction, and there's no negative in the front, so there is no reflection. So I'm going to multiply everything by just 0.5. You can also multiply it by half. You should put half because they give you a fraction in the question. I did decimals just to, I don't know why, I did. So we're going to get 0, 1 times this is this, 0 times this is this, and we get these values. And then we do our vertical shift, and these values carry over. So now I'm doing a vertical shift up plus 2. I get the value from this part and bring it over, so 0 plus 2 is 2. 0.5 plus 2 is this, and I get these values. And then, putting these together, I get the x values here with the transformed y values here to get these points. And now, if I graph it, I'm going to get it looking like this. So it's going to go up to here. 480 is out of our graph, but we can actually assume with this dotted line that it's going to go this way. And if we are at negative 90, like if we made this negative 90, added another row here, negative 90 plus 120 is 30 degrees. So we can see at 30 degrees, it's going to go towards 1.5 here. So we can see the transformations of our regular sine graph, which is shown here. We can see that our graph even looks like it's much thinner. It's like it's been compressed so that the max and the min values are much closer together. So let's talk about the domain, range, amplitude, phase shift, vertical shift, and axis of the curve. So again, I forgot my arrows, but the domain, any real number, our range, well, what's the lowest and highest points? Y is any real number. The highest point it goes to is 2.5, which I put it at 3, but you know what? I think is okay. First, don't notice it now. There we go. So we get to 2.5. Y has to be less than that, and it has to be greater than 1.5. The amplitude is from the equation of the axis, so that seems to be happening at 2. Again, I could double check. 2.5 plus 1.5 divided by 2 is 4 divided by 2 is 2. So from 2 to 2.5, and from, if this is my equation of the axis, from 2 to 2.5 is 0.5, and from 2 to 1.5 is also 0.5. So my amplitude has to be 0.5, meaning the distance from the equation of the axis to the max and the min points is 0.5. We had a phase shift of 120 degrees to the right, and a vertical shift 2 units up. And our axis of the curve we said was y is equal to 2. So that's how we apply all of these transformations to a sine function. So here's some work, and thanks for your time.